Hey, this is Math 6, Unit 5, Lesson 10, using long division today. So we're going to talk about long division a little bit. First of all, we begin with the number talk, estimating quotients. So we want to estimate these quotients mentally, first of all. And so when you look at 500 divided by 7, one thing I would do kind of just mentally is I would turn that 500 in my head into about 490, because that's about the same, right? You're off by about 10, knowing that 7 goes into 49 7 times, which means 7 goes into 490 about 70 times. That's mentally how I kind of estimate that one out there. In this one here, I have a different kind of number. I have 1,394 and a 9. So I might be thinking, well, I'm not quite sure how many 9s are going to be in there necessarily. That might be a little bit different of a problem. Oh, hello, Stevie G. Need a visit. Oh, excuse me a second. There we go. All right. So I might think, well, just kind of estimate things up a little bit. If I know that 9 times 100 equals 900, okay, that tells me that at least I know I'm going to be something bigger than 100, because that's not quite there, right? So it's somewhere close to that. That gets me 900 out of the way, which, in a sense, leaves me about 400 left there. So then I'm thinking, okay, 9 times what gets me close to 400? And that might be something more like, 9 times 40. That gets you 360. So maybe I might say it's a combined 140 as an estimate there. Is that accurate? Not really. It's just an estimate, okay? It's not going to be perfect, but it's pretty close, because that 900 plus 360 is about 1260, and that's not too far off from 1394. And again, we could narrow that down a little more, but that's where we get precise with a different way of doing the division. So for now, it works, and it's just estimations, and we're good to go. Let's look at Activity 2. Lynn uses long division. It says Lynn has a method of calculating quotients that is different from Elena's method and Andre's method. So Elena's method, remember, was she used the base 10 blocks there, and Andre used groups of, but he did some vertical calculations to make kind of groups of 200s and 300s. That was just the other day's lesson. So here's how she found the quotient as 657 divided by 3. Okay? We can see here that she arranged the numbers for vertical calculations here, and her plan was to divide each digit of 657 into 3 groups, starting with the 600s. Okay, so there are 3 groups of 2 inside of 6 and 6. So Lynn wrote 2 at the top and subtracted Stevie G. Oh goodness, kitten. Sorry guys. I've been gone for a few days, and so my cat has missed me terribly, and the whole family. So we're back, and we'll see if we can keep going here. Okay. So we can see here that then she wrote 2 at the top and subtracted 6 from the 6. So we can see this is 2 times 3 is 6, because that worked out well, leaving a 0. And then she brought down the 5 tens, which was here, of the 657. There are 3 groups of 1 in 5. 3 groups of 1 in 5. 3 groups of 1 in 5. So that means you have 1 times 3 is 3. And then she subtracted here and wrote a 2 underneath there. And then we can see she brings down the 7. And she said that there were 3 groups of 9 inside of 27. And then subtracted that for 0 there. All right. So now it says to discuss with your partner how Lynn's method is similar to and different from the drawing base 10 diagrams or using partial quotients method. So just have a little conversation there about what you're noticing here with Lynn's method compared to what we did the last couple lessons with base 10 and partial quotients. Okay? Alright, so there's that part there. Then it says Lynn subtracted 3 times 2, then 3 times 1, and lastly 3 times 9. Earlier, Andre subtracted 3 times 200, then 3 times 10, and lastly 3 times 9. Why do they have the same quotient? Okay, so we can see the difference here is that for Lynn, she's doing 3 times a 2, and Andre did 3 times 200. Well, the difference here is that when Andre did it, he said that this was going to be 3 groups of 200 are inside of the whole thing. And that's why he subtracted it out like this to end up with something along those lines, right? So we had 3 groups of 200 were inside of there. Then when he did 3 groups of 10, right here, he was saying, okay, there were 3 groups of 10 inside of 57, so that became the 30 on his case there, and then 27, and then he did 3 groups of 9 inside of that for that to work out there. So he did the same type of thing, except that he's using the whole number here instead of looking at each digit. He looked at the whole number and then decided how many groups of 3 were in what was remaining there. So it's very similar, but it's a different way. Again, this is the partial quotient method that he did. So I just added it on there real quick. We don't need that for today, but just comparing what Lynn's doing with Andre there. In the third step, why do you think Lynn wrote the 7 next to the remainder of 2 rather than adding 7 and 2 to get 9? The question here is, why do you think she wrote the 7 here instead of combining it with that 2 there? Hopefully you have a conversation here with your classmates about the nature of the place value, right? That this is showing that what wasn't left was 2, but actually what was left were 2 10s, which was 20, and then we're adding a 7 there to make 27. So really this is 20 plus 7 for 27. So that's why you couldn't combine that. If you made it 9, you're taking away the value of the 2. You're replacing a 20 and making it into a 2, and that's not going to work out too well for you. Okay, so let's take a look at the next one. It says Lynn's method is called long division. Use this method to find the following quotients and check your answer by multiplying it by the divisor. Alright, so looking at these next 3 problems, we have 3 problems here where it wants you to use long division to calculate and see if this is correct or see what the quotient is going to be. Alright, so let's do this here. Let's do the first one. We have 846 divided by 3. So I'm going to just do it on a different piece of paper because I don't have space there. So we put a 3 here and 846. And for Lynn's method with a long division, we're looking at 1 digit at a time. So 3 groups of what are inside of 8? There are 3 groups of 2 inside of an 8 because 2 times 3 is 6. And so we subtract that there. 8 minus 6 is 2. As long as this number is smaller than that one, then you did it correctly. Next we'll bring down the 4. So how many groups of 3 are in 24? We would say that there are 8 groups of 3, or 3 groups of 8 inside 24. 8 times 3 is 24. So when we subtract this, we have 0. We're not done. We still have the 6 to bring down. So we bring down the 6. And how many groups of 3 are inside of 6? We would say 2. And 2 times 3 is 6, and we subtract and we have 0. So our solution for the first one is 282. For the second one, B, we have 4 divided by 1816. Alright, any groups of 4 inside of 1? No. So we could put a 0 there, but I don't really need to. How about in 18? Well, there are 4 groups of 4 inside of 18. 4 times 4 is 16. We subtract 18 minus 16 is 2. Now we'll bring down the 1. How many groups of 4 are inside of 21? We would say 5. 5 times 4 is 20. We subtract. 1 minus 0 is 0, and we're good there. We bring down the 6. Now we have 16, and 4 times 4 is still 16. So we subtract there, and we have no remainder, so our answer is indeed 454. And then finally our last one over here, we have 12 and we have 768. Alright, now 12s, knowing my 12s just a wee bit, we would say there are 12 groups of 6 inside of 76 because 12 times 6 is 72. So that works out pretty nicely there. We will subtract and have 4 left over there. We bring down the 8. And then 12 times 4 is 48. We have no remainder, so we know that 768 divided by 12 is actually equal to 64. Alright, so those are the 3 there, just doing some practice here. Activity number 3 is actually an optional one, so you may or may not have done this in class, but it's good practice just to kind of get the feel for things, okay? If you had some trouble with the first 3, then this is good practice to kind of continue here. For all these so far, we've noticed that we've ended with 0, with no remainders, what we call that remainders. Everything has been a nice even number there, 282, 454, or 64. Let's try this one. 633 divided by 3. All right, so how many groups of 3 are in 6? We would say 2. 2 times 3 is 6. We subtract and have 0. We bring the 3 down. How many groups of 3 are in 3? There's 1. 1 times 3 is 3. So we have a 0. We bring this 3 down. And how many groups of 3 are in there? We would still say 1. 1 times 3 is 3. And we subtract it in with a 0. So we're done with no remainders. Looks good. Over here, we have 1001 divided by 7. All right, so how many groups of 7 are in 1? 0. How many groups of 7 are in 10? 1. 1 times 7 is 7. 10 minus 7 is 3. We're going to bring down the 0. So how many groups of 7 are in 30? We would say 4. 4 times 7 is 28. 4 times 7 is 28. We're going to subtract. 30 minus 28 is 2. We'll bring down this 1. And how many groups of 7 are in 21? We would say 3. 3 times 7 is 21, and we're back to a 0. So our answer is 143. All right, very good. Here is Priya's calculation of 906 divided by 3. Priya wrote 320 for the value of 906 divided by 3. Check her answer by multiplying it by 3. What product do you get, and what does it tell you about Priya's answer? Okay, which reminds me, I didn't multiply our answers up here to double check them, so let's just do it here for this part. So let's see, if this is correct, if we take our answer and we multiply it by 3, we should get 906. So when we do it, we have 320 times 3. 3 times 0 is 0, 3 times 2 is 6, and 3 times 3 is 9. And we notice here that this does not match our original starting point of 906. So something is not right with our answer. Okay, so it tells me that our answer is incorrect, right? There's something wrong with it. So what mistake did she make? Well, she first of all said that there were 3 groups of 3 and 9. So 9 minus 9 is 0. So there should be a 0 here. That's fine. And then we can see it looks like she brought this 0 down. And that's correct right there. But if you bring a 0 down and you don't have anything, that means we need to actually put a 0 right here. Okay? And then we bring down the next number. We have to kind of hold that space for that place value there. So how many groups of 3 are in 6 would be 2. So the 2 should actually go here. And then the math works out to be correct there. So what happened was, when she brought the 0 down, she didn't recognize that there were 0 groups of 3 inside of 3 and make a number for that, make a notation of that in her answer. So the answer should be 302 is what it should be, not 320. Okay, simple mistake, but it does happen sometimes. So that's what you got there for activity number 3. Okay, so just to summarize today, just real quickly, we say long division is another method for calculating quotient. It relies on place value to perform and record the division. So you got to keep things in the right places, right? There's our place value all the way through until you get down to a 0. Or if you happen to have a number there, that does become what we call a remainder. Okay, and we can leave it as a remainder, or if the problem wants you to, you could continue this by adding a decimal and a 0 and continuing it until you got to a place where it actually stopped. Okay, can you do that? You could, not in this case here, you don't have to, but that does happen from time to time. Okay, so that's the idea there. I'm going to give you some time to work on your homework, and then we'll come back together and check it in just a few minutes. All right, homework time, Math 6, Unit 5, Lesson 10, using long division. It says Kieran is using long division to find 623 divided by 7. He starts by dividing 62 by 7. So he starts here and looks at kind of 62 divided by 7. In which decimal place should Kieran place the first digit of the quotient, which is going to be an 8? So where should the 8 go? Should it go in the hundreds place, which is here, the tens place, which is here, the ones place here, or the tenths place, which doesn't even exist here, which would be about here? Where do we put the 8 at? Well, are there 7 groups of 8 inside of the 6? Nope, there are 0 groups of 7 there, right? So the 8 would go right here. 8 times 7 is 56, which means it is in the ones, tens place. And that's our tens place right here. So we would say B, tens place. Doesn't ask you to solve it, just wants to know where that 8 is going to go. Okay, that's why you're kind of putting the placeholder zeros there, just to make sure we knew nothing went there. Number 2. Here's a long division calculation of 917 divided by 7. There is a 7 under the 9 of 917. What does the 7 represent? So we're talking about this one right here. What does this represent? Okay. Well, this one here can represent a couple things. We know that this is 1 times 7. Get you to that 7 there. It also means that there are 7 groups of 1 in 9, if we're looking at digits here. Okay, so there's 7 groups of 1 in 9. Okay, or 1 group of 7 if you want to go this way. I think I prefer going this way, 1 group of 7 in 9, but that's just how I like to say it. I don't know if it's right or wrong, that's just what I do there. Okay, it also technically represents, it actually represents 700. If we're being honest about it, because it's in the 100 place value. Okay, so that's what it really does mean. It means that there's 1 group of 700 inside of this number here, because in this hundreds place. So what does the subtraction of 7 from 9 mean? So what does this number here mean? What does this number mean? It means that there are still, basically, this is 7 groups of 100 subtracted from 9 groups of 100. So it's 7 groups of 100 subtracted from 900 leaves you with 200. Okay, so we still have 2 left, which is actually meaning we still have 200 left. This is the equivalent of saying 917 minus 700 leaves me with 217 still to be divided up. Okay, so it's like if you go back to our block method, right? If I have 9 of these 100 squares, 1, 2, 3, 4, 6, 7, 8, and 9, and I have to put them into 7 equal groups. Well, here's 1 group, 2 group, 3 group, 4, 5, 6, 7. I have 2 more that need a home, but I can't give those out equally, so I have them kind of remaining, so I have to change them up in order to give them to the groups evenly. Okay? Next one, why is a 1 written next to the 2 from 9 minus 7? So why is this 1 right there, written there? Well, that's because we have 200 left, and we combine that with the 10 from 917 to show that we have actually 21 tens. So what this is showing me is that I'm going to have 21 tens left. So instead of having 200s, I'll turn these all into tens. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I'll combine it with the 1 10 I have left here, there. So I have 21 of these tens, which I'll then put into all the groups. Now 21 divided by 7 is nice. 21 divided by 7 is actually 3. So I could take these evenly and give everybody 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, and all that's used. So these 200s turn into 20 tens, and I combine it with that 1 10 that was left in order to share them equally. Okay, and then you have the 7 ones left. Those are pretty easy. Everybody gets 1, right? 1, 1, 1, 1, 1, 1, 1. So everybody has 131 when you divide it by 7. All right, next up, Hans' calculation of 972 divided by 9 is shown here, which is on the next page for me. Find 180 times 9. Okay, well, 180 times 9, we do 180 times 9. 9 times 0 is 0. 8 times 9 is 72. 9 times 1 is 9, plus 7 is 16. So we have 1672. Use your calculation of 180 times 9 to explain how you know that Han has made a mistake. Well, if Han's answer was correct, then our quotient here, 180 times 9, should equal 972. And it's not working that way, is it? So I know that he made a mistake somewhere. The question is where? Because this is going to be part C, identify and correct Han's mistake. So Han's mistake, where did he make his mistake at? We can see here that 9 goes into 9 one time, so we subtract and have 0. Han did the right thing, he brought down the 7. That was good. And then he went ahead and brought down the 2 as well. Okay, so what Han is saying here at this point is, we know this part's okay. We're looking at this chunk right here. Han is saying I had to bring in the 7 because 9 doesn't go into 7. So I brought in the 2 because 9 didn't go into 7, so now it's 9 into 72. But how many 9s are in 72? Are there 80 9s in 72, or are there actually only 8 9s? I would say there's 8 9s because 8 times 9 is 72. If we did 80 times 9, we're saying that's 720. Well, that's not going to quite fit inside of 72, is it? So the mistake was, when 9 couldn't go into 7, he should put a 0 right there in the tens place to signify that nothing fits in there. We have to keep on moving. And so that's the mistake he made. So his answer should have been 108. We could verify that by doing 108 times 9 and saying 9 times 8 is 72, 9 times 0 is 0, plus 7 is 7, and 9 times 1 is 9. And this number does indeed match our starting point there. Okay, number 4. Find each quotient. Okay, 5 goes into 4 0 times. I'm just going to put it there. Don't need to, but just helps me remember. I've already used that space, right? So I can't use it again. 9 goes into 46. We'd say 9 times, because 9 times 5 is 45. 6 minus 5 is 1. 4 minus 4 is 0. So I'm going to bring down the 5. And 5 goes into 15 3 times. 3 times 5 is 15. And we're 0 right there. B. 12 goes into 9 0 times. 12 goes into 92 about 7 times. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. So I didn't go over, so that's good. 92 minus 84, I'm going to have to borrow here. This becomes an 8, it becomes a 12. 12 minus 4 is 8. Bring down this 4, and what do you know? It's 84, and I already know that 12 goes in there 7 times. 7 times 12 is 84, and no remainder. 3 goes into 1 0 times. 3 goes into 11 3 times. 3 groups of 3 are 9. 11 minus 9 is going to be 2. So we bring down the 0 there. And so 3 goes into 20. That's fine. 3 goes into 26 times. 6 times 3 is 18. And we subtract. And we have 2. We're going to bring down the 7. And we have 7. And 3 goes into 27 9 times for 369. All right, number 5. This is a review from Unit 5, Lesson 7. It says 1 ounce of yogurt contains 1.2 grams of sugar. That's inside of 1 ounce. How many grams of sugar are in 14.25 ounces? Okay, so if you had like a table, for example, let's say you did a table. You did ounces and you did sugar, like this. Okay, we would say right now we know that 1 ounce has 1.2 grams of sugar. And the question is, if I have 14.25 ounces, how many grams of sugar am I talking about here? So on a table, this is moving 1 to 14.25 means to multiply by 14.25. So in the table world, we would multiply 1.2 by the same thing, 14.25. Okay? But you might just recognize that. So we do 14.25 times 1.2. Okay? And again, we're going to do 2 times 5 is 10, 2 times 2 is 4, plus 1 is 5, 2 times 4 is 8, and 2 times 1 is 2. We're going to put a 0 letter holder space, and 1 times 5 is 5, 1 times 2 is 2, 1 times 4 is 4, 1 times 1 is 1. And we'll add these up, and we end up with 17100. We can see we have 1, 2, 3 digits behind the decimal. So we'll go 1, 2, 3. For 17.1, which matches this one right there. Okay, now do I need to even do the math on this one? That's a good question, right? Let's think about this. If I'm going to multiply 14 by about 1, just estimating, 14 times 1 is about what? 14. So which one of these answers is actually closest to 14? Not close, not close, and not close. The only one that's even close is the 17.1. So you probably could have just estimated to show that that was actually correct in that one there. All right, one more, number 6. It says the mass of one coin, is 16.718 grams. Okay, The mass of a second coin is 27.22 grams. How much greater is the mass of the second coin than the first? So we're comparing, right? Coin 1 compared to coin number 2. How much bigger is it? Is it greater, less than? What's it going to be? Let's find out. So we have two numbers, 16 and 27. So I put the greater one on top. And when I'm comparing numbers, that's a subtraction kind of problem. And we notice here that there's no thousands place in the top number, so we can add a 0. That's fine. We're going to borrow. 10 minus 8 is 2. 1 minus 1 is 0. I can't do 2 minus 7, so we need to borrow. 12 minus 7 is 5. Keep my decimal place lined up. 6 minus 6 is 0, and 2 minus 1 is 1. So how much larger is it, the second coin? 10.502 grams. All right, and that's it for today in today's lesson. Have a great day, and we'll see you next time.